In this video, I'm going to introduce you to the idea of exploratory data analysis. So exploratory data analysis, or EDA as it's often abbreviated, is a good first step to take with any data set. It's what we call the process of trying to understand the data that's in the data set and get an idea of the kind of useful insights that we might be able to get from the data, as well as any potential problems that the data set might contain. The problem with datasets is that it's hard to just look at the raw data itself and get an idea of the kinds of information that we could get out of this. For example, here's a data set stored in a variable called heart disease that we'll be using in the rest of this video. And if you were just to look at these numbers, it would be hard to say what sort of patterns we might be seeing in different variables. So the solution is to try to simplify the data down. And there are two main ways we can do that. The first is by calculating statistics. So for example, you calculate the mean of one of the columns of data. The second main way to simplify data is to convert it into graphs. And when we convert columns of information into picture format, we can often see patterns that otherwise we wouldn't be able to detect. So the general process for EDA looks something like this. The first is just to get the data, right? Download the data to your computer, read the documentation that might be provided with the data set that will tell you a little bit about how the data was collected and what types of information are in the columns, and then take a peek at the data itself by trying to open it up within RStudio. Then we embark on sort of a cyclical process of exploratory data analysis. We might say, what is some sort of question we could ask about the data? Like, what is the distribution of the data in a particular column we might be interested in? We do something to try to answer that question, such as by creating a graph. And then when we look at the output we get, we might answer our original question, but often we'll generate more questions in the process. And so then we jump back to step one of the cycle and repeat the process. So what does getting and verifying the data look like? Well, let's return to our data set about heart disease. This is the data set that I downloaded from the machine learning repository hosted by the University of California, Irvine. And every row in this data set is a person who either has heart disease or doesn't have heart disease, along with a bunch of medical information about that person. We can use a function called head to print out the first few rows of this data set rather than displaying all of the rows. Often when you have a larger data set, you don't want to look at all of the rows at once, but looking at a few of the rows can give you some insight into the types of information that are in each column and can sometimes show any problems that we might have. Typically, when we're exploring a data set, we're interested in looking at the variation within each variable. And there are two types of variation that we're interested in. First is what we call univariate variation, which is just the variation within a single variable. Another way we might refer to this is the distribution of that variable. Then we're also interested in the variation between variables, i.e., how do they covary? As the values of one variable change, how do the values of another variable change? We call this multivariate variation. So we said that one way to look at a data set is to calculate summary statistics. And here's an example of how we might do that using a function called summarize. And we can take that big data set about patients and calculate the mean age as well as the minimum and maximum ages in that data set. And so by calculating summary statistics, we can get a quick numerical summary of what's in the data set. The other thing we can do is visualize the data. So here again, we have the age column, but now we have turned all that data into a histogram. And visualization allows us to do a few things. We can characterize relationships between variables. So if we were to look at the covariation between two variables, we could try to see, is there a linear relationship or a curved relationship? We can also look at hypotheses about our data. So we might have speculated ahead of time that heart disease was correlated with age. And the other thing that visualization is often good at is helping us to see problems with the data. So data that has been incorrectly entered might jump out, as well as data that's potentially outliers.